Hello everyone, welcome to section 1, lecture 2 in cartography. Today we're going to talk just a little bit more about what goes into a map, go into a little more detail on some of the concepts I brought up in the last lecture. So what we'll cover is to distinguish a bit more between what is considered map art and map science, and also go over some more fundamental concepts such as scale, map elements, design principles, and presenting geospatial statistics. So I had this slide in the last presentation, but I wanted to go over it one more time, which is the philosophy of the map, which is just a solid reminder about what maps are and what maps aren't. Maps are static, while the GIS data we put into them will often be changing. So that's something to keep in mind as a reader of maps. Remember that any map is a snapshot in time of a particular phenomenon. And that relates to the first point. Maps are only looking at one particular moment, and again, data is actually always changing. And like any written material, maps have a message and an audience, and it should be clear and easily understood from the moment you pick up or unfold a map or open a web page. And given that, communication happens through good visual design as well as good science. And because maps are tools of communication with a human author, they are also subject to bias. Also something to keep in mind both as a user and a creator of maps. So this is why we always sort size materials and statistical methods and an author name. And maybe let me just reiterate the point that map making is both an art and a science. There is a design, subjective element, but there's also a scientific, analytical element to it. So the first thing we'll go into a little more is map art. I included this quote here. I thought it was kind of a nice way to think about the impact maps can have on us. It says, maps encourage boldness. They're like cryptic love letters, and they make anything seem possible. I'd like to start the map art section on this because it is true. Like, there's a lot of romance and mythologizing involved in maps, and I think when we talk about art, we kind of can get a little more into this idea that maps can be these powerful tools, not just for getting you from point A to point B, but for actually inspiring your thoughts and your imagination about what you're possible of and what the future holds. So looking at something a little more pragmatic in the map art section are the basic map elements. So these are all the things that go into what you see on the map that you have artistic freedom over. So we'll just go over a couple of these things. We have our neat line. Neat line you've probably already heard of if you started doing your labs. And that goes around the map itself. It's kind of just like the border, which is also an element of there. There's the title, pretty self-explanatory. A legend, a scale bar, credits, north arrow. These are all things we like to see on maps, very common elements. The ground is what we refer to as the background, more or less. So it's the sort of the empty space around the map itself, the figure image. And we also have things such as the insets. Not all maps have these, but a lot of them do. And also place names. You can't have them, well, you can't have a map without a place name, but in general, this is something we definitely seek to have on maps. And I note on here on the side, it says, not all of these are necessary or required for a map, and one should always choose the information and design elements relative to the communication goal of the map. And we'll go over a little more about, in the coming weeks, about what exactly you're trying to achieve and what you can or cannot or don't need to include. So also part of map art, of course, is the typography, color, and layout. And to me, this is where you really kind of get into the artistic side of it. I say ironically, since this is map art, there is a science to color. There's a whole lot of information and thinking devoted to what colors work best, how to communicate best with colors, and what makes the most impact depending on the subject matter. Typography also matters. If some people have an eye for it, some maybe aren't as experienced at seeing it, but perhaps after this class you'll pay a lot more attention to it. Font sizes and font style can make a map cryptic or easy to read and comprehend. This is very important. It makes things a lot easier, and it's one of those elements that you probably don't even take on board when you're initially looking at something. But when you start thinking about it, you realize what a difference it can make to how you view the information. And finally, layout. Layout is very important. Again, we'll be going over that in the coming weeks. How you balance out the flow of information and on the map. And there's a hierarchical element to how that happens and a little bit of a technique to it. So these three elements work together to form the basic elements of well-considered map design. I didn't mean to put the word element in there twice, my mistake. So moving on. These are my map preferences. This is just stuff I like personally as a designer. I don't like to use neat lines. I don't always use a north arrow. Sometimes it's pretty self-explanatory which way is north, but then again, it also depends on your audience. So like I say in here on the slide, it says, if you have a map of the African continent, we can generally assume the reader knows which way is north, but it depends on the audience. And if we're looking at school-age children, we might need to actually make that clear. I really like using complementary fonts in typography. So I like to have a title in one font and then the subtext at the bottom in a different font. Legends don't always need to say legend. We know what it is. Again, we need to sort of take out the obvious on things, I think, and just get straight to the point. And the title needs to be super descriptive. We'll go into what I mean by that in coming weeks. And coloration should enhance the communication strategy. I kind of touched on this in the last slide, but it's important to actually see if there are pre-existing standards for the different color schemes you choose, because certain industries or fields of study actually have standard colors they use for things. So moving on to the map science, another quote here, which I just think is kind of funny. Geographers never get lost, they just do accidental field work. So this is just to say it does tie into the idea of map science, which is that as analytical and as thinking through processual as map science is, or doing things that require map science, there's a lot of experimentation. And sometimes, and this just happens with research in general, you come up with results and answers you didn't know you were going to have. So that's why we should just embrace the unknowable nature of doing research. So the first thing I wanted to introduce when I talk about map science is the concept of scale. This is something I actually struggled with a little bit, and I wanted to actually present this to you because for me it took a while to kind of put it together. So first off, when we talk about scale, there's the literal scale that we'll have on the map. We'll have our scale bar. And you can represent that with a verbal scale, which you see in that center column, or a representative fraction. But I think a verbal scale is much more standard because it's the way we can more easily conceptualize what the measurements on the map are compared to in the real world. So a map will always tell us the literal scale of the map, but what exactly is meant by large and small scale? So the way I make the distinction, I'm going to move over to the next slide just to sort of illustrate this point a little better. So small scale are things that appear on the map as small, which means you're looking way far up. You're a bird that's a mile above North America, or let's say in this map I have Glasgow. Whereas large scale means you're only 500 feet above Glasgow. So when it's large scale, things on the ground look large. When you're small scale, things on the ground look small. So I'm going to go back to the last slide because there's a few other ways to think about this. Small scale, features look small. Large scale, features look large. So under the small scale text here, I say, just to confuse things, on the verbal scale, the distance one unit represents gets increasingly large, but on the representative fraction, the number also gets larger. So there is a larger amount of area with lesser detail versus where large scale, it's the opposite, a smaller amount of area with a greater amount of detail. And the point I make at the bottom is that all this terminology is not fixed, but exists in comparison with other map scales. So to look at one map, yes, I mean, generally you can say this is small scale, this is large scale, but all these things exist in relationship to each other, and that's really going to give you an idea of where something is at on this relative scale. So a little bit more on map science here, statistical classification methods. We will, again, be going into this a little more, but just note that what I'm going to be talking about over the next few slides, this is a whole other sub area in doing GIS, which is called spatial statistics. And we're going to touch on it a little bit because there's a lot of very easy to use but powerful tools we can do for doing breaks in data. And doing breaks in data is how we can, or classifying data is how we can make the way data looks and says and what it says, and we can manipulate it based upon where we put breaks in the information. So if you look at this example I have up here, it's kind of small, but you can see for A, for instance, this is called natural breaks, B is called quantiles, C is called equal interval, and D is called standard deviation. I'm not going to go into right now exactly what those 4 different things mean. We'll go into that later, but suffice it to say that each method for breaking up the data can show the reader a different story, can tell a different story. So at each map here, we're looking at the same information. And I'm trying to look, oh, it's for United States housing. But because of it's broken up in different ways, it actually tells a very different story for each map. And so I just like to highlight this at this point because it tells you that there's a lot of interpretation that goes on when it comes to this. And we see a lot of these kinds of maps in the media. And it's important to understand and be critical and be aware of how someone is representing data on maps like this, because it can be manipulated to tell a certain side of the story. So quickly we'll talk about different map types. We'll use this quite, this is the major division in map types. We have reference map versus a thematic map. A reference map shows us the location of features, whereas a thematic map is a map that displays a theme or attribute of a feature. So those maps we just looked at in the last slide were thematic maps because they showed us the housing in the United States, depending on, I think, housing per capita, versus a reference map, which we'll look at in the next slide, which is just showing where things are. So this is a good example of a reference map. It's very dense, but it does kind of get the point across of what a reference map is. We have borders, we have boundaries, we have roads, road types, place names. We can see the neighboring states. Things it could have, but it doesn't, which is probably good because it would just get too busy, are mountains, rivers, valleys, railroad tracks, elevation. But all this stuff goes into what is contained in a reference map. Thematic map types. We have choropleth, which is what we've already kind of working with that a bit in our Lab 2 map, and Lab 2 from the chapter, or from the textbook. Proportional graduated symbol, dot density, isarithmic, cartogram, asymmetric. Each map type is derived from different forms of statistical analysis of the attribute data, and what you choose depends on what kind of problems you are addressing. Again, in a similar vein to what we were talking about with the way classification breaks can influence a map's message, so too can the way you present the data in these different kinds of maps. So in these next slides, I actually have examples of each of these kinds of maps. I'm not going to go into detail what they are right now, but you can go through this and just read the description and also just get a visual idea of what it is, what is meant by each of these terms. This is choropleth, so you can see it's the range of colors. Graduated symbol is using symbology, as we see here, it's circles in different sizes to represent the intensity or the size of the whatever phenomenon you're featuring in that map. The dot map is using dot density, so it's 1 dot per occurrence, and it can be another great way to sort of show the intensity of occurrences of a phenomenon over a geographic area. Isopleth, this is a lot of generalizing your statistics, but this is what a lot of weather maps are based on. And cartograms, this is getting a little more complex. It's looking at maps as, or the data that goes into maps as influencing the size and the shape of, in this case, it's the continents. And asymmetric, I'm not going to try and explain it to you right now. It's a little confusing, but it's there. You can read it. So GIS and the map of the science. So the data view is, this is what I'm showing you here is actually ArcMap desktop, but it's no different in ArcGIS Pro, which is that we have our data view where we actually conduct the data, the analysis of the data that goes into the map. Whereas the layout view is where the art occurs. So To end, I'd like to just sort of highlight how GIS is fundamental to all of this and to watch the video down there called Do Maps Lie?